Science. Greeting, as soon as Armpit here yet again, and welcome back to AEL. If you're new to this channel, please consider going down below and subscribing. That will help me out immensely. Now, I just introduced myself as soon as Armpit because someone said that in a comment somewhere else and I found it funny. Anyway, the Astro 30 here yet again, and it's been a few weeks, and sitting on the desk now is the revision C of that mixer preamplifier that I had problems with in the previous video, which I will link in the description. The assembly procedure is the same, so I didn't film any of that, and I painstakingly assembled it last night, and by painstakingly I mean that I recovered all of the capacitors, headers, pots, and even that socket, which was a pain in the ass to get off the board, but I managed to do it. The only components I didn't save were the resistors and the two diodes. I just used new ones. They're cheap enough anyway. So I'm ready to test this now, and I thought I'd bring you along for the ride. So what I need to do now is I need to get set up with the oscilloscope and signal source, etc. And just to note, I've got a 47k resistor jammed in the end of the input connector here because the first input stage is an inverting op amp, so it will not work without Rin, or the first input resistor, which are actually 47k and they're on the input boards. So each input boards has a 47k mix resistor, so that forms the input resistor to this stage. And as this is a summing stage, it will sum all the inputs together. So let me get set up to test this, and we'll have a look at what we got. Okay, I got my portable oscillator set to a sine wave of 1 kilohertz, and the amplitude is all the way to 0. Got it hooked up to the circuit, and the preamp's output is connected to the oscilloscope on the yellow trace, and I've got each of those potentiometers set to roughly halfway. The scope is set to 1 volt per division. My power supply's load switches are on, set to 15 volts plus minus. All I need to do is turn the power on. Now, nothing happened yet. Didn't even see a blip on the scope, which is okay. I'll increase the amplitude, and my time base is wrong. But as we can see, we are getting a reasonably nice sine wave, and I'm in 1 to 1, so that's good. So we're currently outputting about 1.3 volt peak to peak. Let me play with the master volume pot. Oh, absolutely, look at that. So I don't know what I'm putting in, so I'll drop this to 2 volt per division. 2.5 actually. That is awesome. So let's turn the master up full. There we go. And I'll drop this until it stops clipping. It's about there. Readjust my time base. And not my time base, my voltages per division. I can't go any further than that. So I'll switch over to times 10 mode on the probe. Like that. And I will change this to times 10. Okay, there we go. So we're getting an amplitude before clipping of 28.2 volt peak to peak, or 9.9 volt RMS. That is working as an amplifier. So I will look at what the input sensitivity is in a minute, but what I want to do is I want to change this to a square wave, which is not the best looking square wave, but it's a square wave. I'm going to test the operation of the base pot. It's doing what the base pot should do. Good, that's working. The mid-range pot, yeah, that is doing what it should do. And now the treble pot. It's subtle, but it's working. So those pots are working. So I'm going to change this now back to a sine wave. And I'm going to just look at what the input sensitivity is, like what the voltage going in is. So I'll just connect my probe up to the input resistor. Now I'm not seeing much at the moment, so I'll put that back. I might have to increase the voltage per division. There we go. 2.4 volt roughly peak to peak, 796 millivolt RMS to give us 28 out. So yeah, okay, that's a pretty good amplified signal. So I'm happy with that so far. So we know what input's going in. I've just lost my ground wire, so I'll reconnect the ground wire. Okay, so now I'm going to switch over from this output to the line output, and there we can see there's a signal at roughly 6.4 volt peak to peak, 2.2 RMS, which is about line level, and that's not going to be affected by the master pot, nor is it going to be affected by the headphone pot. So the line out part works. So now I need to test the balanced output, which means I'm going to need to get another oscilloscope probe, and I need to put two probes either side of it and find a way of grounding it. There's a ground post over here. So let me get that part set up. Well, interestingly, from the balanced output, there's just noise. There's no signal on either channel, and I know there was to start with. However, I could have a dead op amp, so what I might do is I might swap that op amp out and see if that makes a difference. No, it's not the op amp. There's something else wrong with the circuit here, and I'm not sure what. All the components are in. That's kind of annoying. So we should have an output rather than just noise. So I'm confused at this point, unless I buggered up the routing somewhere else, which would be really annoying because this PCB cost me like $28, well closer to $40 to have it made. I don't want to have to do it a fourth time, or a third time in this case. So I don't know. Let me probe around with the oscilloscope, signal trace it and see where the signal disappears. Never mind, that was a brain fart on my behalf. The ground lead on the input came off, so that's why there was no signal, just noise, because there was noise throughout the whole entire preamp. So yeah, and then I looked at the input and it's like, ugh, the flylight wire came out. Anyway, we can see here that both channels are roughly even. We've got about 8.2 volt peak to peak roughly, and about 2.8 volt RMS on the balanced output. One is 0 degrees and the other is 180 degrees out of phase with the other. So that indeed is working. So brain farts aside, let me just hook up the headphones, and I can hear that it's coming out of the headphones. It's coming out both sides, so that socket's still fine. I just want to somehow measure, if I can, measure the headphones output amplitude. I might have to just touch it to it to do it. Okay, we can see we've got a signal there. It's not very strong, but that's driving into headphones. In fact, they're 33 ohm impedance headphones roughly. We're getting about 100 and 200 odd millivolt peak to peak, 56 millivolt RMS, which into headphones is considerably loud. So I might just actually unplug the headphones and measure it unloaded. There we go. So unloaded, we're looking at about 500 millivolt peak to peak, or 170 millivolt RMS. And yeah, it does go quite considerably far before it clips. There's the clipping. Back it off. So unloaded, we're looking at 2.7 volt peak to peak, almost a volt RMS. So yeah, cool. Everything is working as it should. I'm quite pleased about that. So the next step would be to test it into a power amplifier with the input module. However, that's going to prove more challenging. Not because it's impossible to do, but mainly because of my setup. This is my power amplifier testing power supply, and it's up here, and I don't have enough of these banana connection type plugs to plug into the banana sockets. So if I was to rig it up, I'd have to jerry rig it to make it work, which, yeah, could be proving challenging. However, I might be able to pump the output signal of the preamp via this lead here into the, oh that stunk, I just farted too, into the input of the Samick Smart 3's guitar amplifier that I've got knocking about, and keep the gain low, and just, you know, it's not really going to be a good test. It's just that I don't want to have all these wires that have the potential to short on each other hanging around the desk at the moment. I will have to set this up a little bit better in the future, but for now I think that's what I'll do, is I'll hook it up to the Samick amplifier and just play around with the controls. I'll hook the input board up and we'll just have a little bit of a listen. Alright, so I've got the preamplifier hooked up to the Samick. The gain on the Samick's turned down. Master volume's about halfway. The input is about a little less than halfway. I forgot to mention that this input board is set for guitar, so I've got my bass guitar hooked up to the preamp input board. So this is so far how it sounds. It's not bad, so we'll try some bass. Whoa. Yeah, okay. No bass. The bass and treble on the amplifier are set half mast. So let's give it some mid-range. Okay, that's doing what it should do. Treble. I mucked my scales up. Yeah, okay. There we go. Finally got a scale out of it. I'm way out of practice, by the way. It's because I've got a jump. Cool. That seems to be doing what it should do. So yeah, the amplifier's distorting a bit, but that's fine. So we can tell and we can hear that the preamplifier circuitry is working, and working properly this time, as it wasn't last time. Eventually I am going to release these PCBs as a project on PCB Way, but just not at this moment in time. Reason is because I've got to do a bill of material for both boards, and I've noticed a lot lately that they keep contacting me, well at least twice anyway, because people want some of my projects assembled by PCB Way, and they keep harassing me for correct part numbers and manufacturing details on, like, you know, an NE 555 timer or a JST socket. It's like you can't do the research for, you know, the 5 minutes that it took me to find the parts for you. Okay, maybe you shouldn't be in electronic assembly if you don't know what a part is. Anyway, if it was something obscure, like an MAX processor IC or something, yeah, well, maybe. But not for an NE555. Anyway, I'm getting off topic here. The circuit works, I'm happy. I can put this away and move on to something else for a while. So this is where I'm going to leave this video here. And if you enjoyed it, please remember to go down below, like, comment and subscribe if you haven't done so already. And this is the Astro 30 saying, see you in the next video.